Hello and welcome to the channel. Today we are going to be discussing a project I've been working on for a while around Airsoft Pyrotechnics triggers. So before we kick off, please, if you like today's video, hit the like button, and if you want to see more of the content, please subscribe to the channel. So we're going to be talking today about the MK2 Airsoft Pyrotechnics trigger that I've basically been working on. A little while ago I started developing some trigger devices that can be used to trigger airsoft pyrotechnics. And the first sort of output of that was this guy here. This is my MK1 trigger. The MK1 trigger is designed to trigger one of these, which is a electrically initiated pyrotechnic device. This one is a MK5. And it essentially operates by applying a voltage across two wires, and that will then detonate a small charge which is in there. That is basically what we'll be detonating. This MK1 device essentially is a very simple system that is designed to trigger based on movement and will set off a pyrotechnic device once some movement is being detected. What I'm going to do is take this out of the way, and effectively, just to recap what's in that MK1 device, we have an Arduino Nano, which is essentially the brains of the device. We have a passive infrared sensor, which is used as the triggering device. And then we have a relay, and that's used to control the voltage that's applied to the pyrotechnic device that's essentially attached to it. And effectively this acts as an isolator for the power used to trigger the device from the controlling circuitry. So this MK1 device does work, and it works relatively well. However, there are a couple of drawbacks with it. Essentially the main drawback is the fact that this device is essentially quite dumb. When you plant the device, it will essentially arm, and at what point it's armed, it is essentially going to go off. That is pretty much how this device works. It essentially will go off. There's kind of no stopping it. There is an arming switch on the front, but once it's in the arm position, in order to actually turn it off, you have to get to the front of the device and turn the switch to the off position. The problem is the sensor is mounted on the device just above the trigger switch, the arming switch, at which point to get to it, you have to get into the field of view of the sensor. And as a result, it will more than likely go off. So this innate ability of the device to pretty much always go off does mean that the device has essentially a limited set of uses. In essence, these uses basically mean that the device can only be placed in locations where you are only going to have the device go off, or you don't need to disable the device to traverse through the region it's essentially protecting. So if you're using one of these for example, for base defense, you can't use the MK1 device on a route into the base that you will use often. And this as a result is why this is one of the reasons why the MK2 device came along. The MK2 device essentially enhances that MK1 device to enable you to control the device so you can pass by the device safely. It also basically means you can disarm the device as well. When you've done for the day, no one's triggered it, you can go, instead of going up to it and having to trigger the pyrotechnics to actually get at the device and then disable and render it all safe, you can send the device a command to turn it off and disarm the device. So the MK2 device is based around a different microcontroller board. This is the board that we're going to be using. It's from a different manufacturer, but it is essentially an Arduino board. It has the same kind of concepts with the various different I/O pins. However, it does have a major difference. The major difference is the inclusion of a GSM module, which basically allows this device to communicate on a cellular network. There are versions of this board which have a Wi-Fi chipset attached or a Bluetooth chipset attached. However, I chose here the GSM device because it means you do not have to be strictly within a tight radius of the device to disable it. You can disable it from a greater distance. So basically, with this, you send it a command via the cellular network, and it will then perform the action based on that command. So the other major difference between this and the Arduino Nano is essentially how this is powered and how this works. The original Arduino Nano used essentially one of these little units with a IMR battery in it. This enabled us to get 5 volts out. We applied those 5-volt power elements to the different elements of the system. So for instance, the relay got 5 volts, the Arduino Nano got 5 volts, and the sensor got 5 volts, all from here. And this works well. You know, it's essentially one battery, but there is a drawback to this. The GSM module requires a lot of power. Essentially requires a lot of current. And as a result, we had to switch the battery type. So basically, this device uses one of these, which is essentially a LiPo battery, the same sort of battery you have in a cell phone. In fact, this is pretty much the same sort of milliampere hours you would have in a lot of cell phones that you have today. A lot of smartphones will use a battery around this size. Some of the more modern flagship phones will have bigger batteries, but a lot of them are around this size. And this basically is enough power to control this and everything else. This also runs at different voltages. Because this battery pack is only 3.3 volts, 3.7 volts, everything on this is at a 3-volt logic sort of level. So that basically dictates how all of the functionality on here works and how it interacts with the devices attached to it. For instance, this guy here, this relay does operate on 3 volts, whereas this relay operates on 5 and actually requires a 5-volt supply, but also requires 5-volt switching and everything else. And when doing initial testing using these two together, there was a lot of issues with the switching. Effectively, there wasn't enough voltage applied when the logic was to essentially turn this off. So this operated on a low, when it was essentially the inputs were taken low, this would switch on. When the inputs were high, this would essentially switch off. And the problem with this was the 3 volts that came out of this unit as the switching voltage was just not high enough to basically get this to switch off. So this was essentially an active low switch. This is an active high, so it's opposite, but it also operates off 3 volts. So you can provide this 3 volts and it will work fine. This guy here, the sensor, this is unchanged from the Mark 1 device, but there is an issue with this one. This is actually a 5-volt device. However, there is a workaround to enable this to work on 3 volts. So let's put things together and I'll sort of wire things up and sort of show you how this actually kind of fits together, and then we'll see it kind of running in this sort of prototype state. So first things first, I'm using a breadboard to enable me to just sort of build things together and distribute power and everything else. So I'm going to pop the relay onto the breadboard, and now I'm going to set up the power for this. So I'm going to just take some wires here. What we're going to do is this is going to be our power rail. I'm going to use red and brown cables. I don't know why I decided to use those, but effectively I'm going to use red and brown for this. Let me just get these in. Sometimes they're a little bit annoying and they don't quite go in properly. I don't know why, but sometimes they just don't want to go in. Right, so those are in. Our 3 volts essentially is applied to there. Oh, it's one way around. That's ground. So the ground actually goes to there. And 3 volts goes to there. So that's powering our relay. Now we're going to take power from our Arduino board, and so essentially power is presented on this pin here, and the ground is presented on this pin here. So I'm going to connect some power leads to this, and effectively that's going to then form the basis of our power rail, which we're going to basically set up here. So we're essentially providing power from this to this rail here, and then we'll distribute that to the sensors that are on here. So I mentioned a workaround. Now the workaround on here is essentially this chip. This chip actually operates on 3 volts. This entire circuit has a essentially a voltage regulator, which takes 5 volts and essentially steps it down to 3 volts to power this chip. So with that in mind, at some point on the circuit there is essentially a 3 volt rail which attaches to this chip. This is the thing that we need to actually operate the entire unit. None of the other components, for instance the actual sensor on the front, operate at 5 volts, they all operate at 3. So effectively all we need to do is provide a 3 volt rail. Now, as luck would have it, this jumper on the side here is used to control a feature of this chip. And it does that by applying a voltage to a pin on the chip. And so the center pin of this jumper is either taken low to disable a feature and taken high to enable the feature. Or it could be the other way around, I don't necessarily know, but that's actually in material because we don't want to use that feature. What we actually want to do is that pin that's currently exposed actually is on the 3 volt rail. So we actually want to provide power to that 3 volt rail so we can connect our 3 volt rail to that pin, and all of a sudden we have power. Next we connect to the ground and we attach that to our rails on the breadboard, and we essentially have powered everything that we need to power on this, and we are good to go. So that is essentially pretty cool. So we've got all the power wired up. We haven't applied any power yet, but let's get some of the signaling set up. So we want to take the signaling from the sensor. Now, just to kind of aid us as we do this, what I'm going to do is I am going to connect the sensor to the breadboard, and then the breadboard to the Arduino. But at the same time, I'm going to connect this guy, which is a logic analyzer, to the breadboard. And then 2 of the channels on this logic analyzer I will then connect to the various inputs and outputs from this circuit, because it enables us to see what's happening when we're switching. So first thing I'm going to do is I'm going to connect the signaling of this, which is this pin here, to a point on the breadboard, which we'll do there. And then we're going to connect pin 0 on these headers to the signaling. So pin 0 is essentially the 3rd pin up on this side. So I'm going to connect to this pin here. And then I'm going to connect that to our line on the breadboard, and then I'm going to take this, which is on the first channel, on channel D0 on the logic analyzer, to monitor that. Next up, we're going to connect up the relay. So to do that, I'm going to connect pin 11 on here. So I need to find pin 11. And I'm going to basically do that to there. That's an output. Pin 11 is going to be connected to this center pin on the relay. And then just to enable us to monitor, we will plug that into there. And then we'll plug that into a channel on our logic analyzer. Okay, so we've connected everything up. I've applied some power. I have had to disconnect the switching signal line to the relay just because I've noticed there is an issue, which is something I'm going to have to look into. But what I'm going to do is now show you it operating and switching based on its current process. So what I'm first going to do is switch over to the PC with the development software on there. What I'm going to do is I'm going to push the latest version of code onto the unit, and then I'm going to open up the monitor, and we'll have in a second. Okay, so it's now starting up, and basically it's just running through the initialization and essentially a wait period which is used to calibrate the sensor, and in effect, once that's done, we'll send a text message to arm the device. It's got essentially two modes to arm, one to arm, one to disarm. So that should be done any second. So with that done, it's going to start waiting for a text message. So I've sent the message. It'll take a second or two to arrive. Once that does, it will arm the device. So still waiting. It's going to traverse the mobile networks, obviously. And now it's received and it's now armed. So the sensor is now active. So just in the serial console here, I'm just going to show you it triggering. So I'm going to put my hand in front of the sensor. We've got a motion detection, so that's actually triggered. The motion ended. And now if we wait a little bit, it should reset essentially the signaling line for the relay. And that takes about 30 seconds. So there we had that. So we have the logic analyzer connected, so we can see how this looks. So if I just set this off, and as you can see, basically both D0 and D1 are for active. Essentially, they're both low, so there's nothing happening at the moment. The idea is the relay will trigger when a high voltage is applied to the signaling pin. And so if I put my hand in front of the sensor, you'll see it rise up, and we've got a high voltage applied to the signaling pin for the relay. That will be held for about 30 seconds or so, and that should drop. And it's actually not 30 seconds, it's about 10 seconds. And that will drop. And so we put it again, you'll see we've got another signal, and that drops off the motion sensor, and we have the signal being applied to the relay. That will drop any second, and there we go. And so basically that allows us to sort of trigger and arm based on the mobile signal. Now, if we go back to the serial console, and what I'm going to do here is I'm going to disarm the device. So effectively, the device is armed and it's waiting for text messages, and I will basically send it the disarm command, and that will get sent through the mobile networks. Take a minute. So just waiting on that to arrive. It's got the message now. It's disarmed the device is now safe. So if I move my hand in front, we're no longer getting the messages saying that the device is detecting motion. The device is now safe. The relay could not be triggered. Essentially everything is now essentially turned off from the switching side of things, and there's no way to re-enable that. So effectively that is basically how this device works. So that is basically the prototype of the Mark II. It is essentially 80% functional at this moment in time, and there is one issue, and that is down to this relay here. What I'm getting is essentially a feedback problem, which I need to investigate. Basically what we have is, with this connected to the signaling pin, when this relay actually triggers, effectively we're getting a spike in voltage in the rest of the circuit, which causes the controller to think there is movement detected. And at that point, the relay is reinitialized to a high state and therefore a trigger state, which is not what we want. And so what I need to do is investigate some way to essentially isolate this circuit so that doesn't happen. I think we need either some isolation of the voltages on the various lines here with the filter, essentially to kind of prevent the noise from the relay making it into the signaling lines and causing the problem to essentially manifest itself. So what I think is happening is, when we trigger the relay, there is noise essentially getting put into either the VCC and the ground, or basically it's going into the actual wires itself. So that is the Mark II unit. It is prototype at the moment. We do have a small niggle around the relay, but the software that controls it works, the sensor works, and the signaling to the relay works, but the relay itself, we have an issue with essentially electrical noise. So we'll be working on that to sort of finalize that out. This is basically a rather interesting little piece of kit. It will essentially go into the same housing as the Mark I device. It's a nice big housing. It's got plenty of space, and we can pack everything in that we need to pack in, and that will basically make a useful Mark II unit. And so I hope to have this fixed and sorted. Once I have, we'll have a second part to this video, which will actually have the finalized unit running for demonstration purposes. So with that, thank you for watching. This has been kind of a rundown of the prototype of the Mark II Airsoft Pyrotechnic trigger, which is a cellular controlled unit, which enables me to arm and disarm the device remotely without having to worry about wasting pyrotechnics, as the device is connected and pretty done to operate. So if you found today's video useful, please hit the like button, and if you would like to see more of the content, please subscribe to the channel. Thank you for watching. Goodbye.